还有谁没来吗？1、2、3、4、5。哦，德辉 ，OK， 好。Okay, so let's continue. Last week we were talking about the hydrogeological surveys concept. So there will be some of the background information for you to understand. And following, we are talking about one of the cases for the hydrogeological survey in the mountains area in Taiwan. And this project is operated by the Sinotech engineering consultant companies, and they were supported by Central Geological Survey at that time. And right now we call the Geological Survey and Mining Management agencies. So there will be the name changes. So the main content will be they would like to construct observation wells in the mountainous area to understand the groundwater resources in Taiwan. So spend 12 years with 3 phases from central Taiwan to southern Taiwan to the northern Taiwan. And the main content will be several, like they include the geophysical survey, using the geophysical survey on the ground surface to understand some of the background, like the geological material or structure. And that's occupied by the E3 industrial companies. And another could be geochemical surveys, also occupied by E3, operated by E3. And they take some of the water samples, include the rainfall, surface waters, and groundwaters, to do some like isotope analysis or chemical analysis, and try to see if the water qualities match the drinking quality or the source of the drinking waters. And another part is to understand like the source, where could be the main source is from the rainfall or from like groundwater discharge, what we mentioned, the best flow, or it could be from much deeper, like they could be, we know like geothermal system, they could be from a very deeper groundwater to outflow, like spring. So there could be some of the sources from different kind of the area. So using isotope or geochemical data, they might able to understand the background. And another part will be operated by the Sinotech engineering consultant company. And there will be mainly for the geological survey during the drillings. So this project is mainly done by them. So they will try to find the place and to do the geological drillings, and then try to recognize the geological material or like the structures or the distribution of the materials. Try to find out where could be the high potential area for the water resources, and try to understand some geological background, hydrogeological background in the mountains area. Like they might select the several formations because we have the geological map in this area. So from the geological map, they will know where could be some of the specific formations or the geological material. So they try to do the drillings in that area to take the sample and do some laboratory experiments, understand like their hydraulic properties or even mechanical properties. And another part is they doing the in situ test, like they using the pumping test, slag test, or the lotion test, the others methods, because they're using the pakers to seal the system and do the pumping test in the specific depth. So they become like a partial confined or the confined system. So the method will be a little different from our what we learned, the pumping test or the constant head or falling head test. Okay, so after they conduct several experiments, they will collect the data and try to categorize like what kind of the formation, what kind of geology materials have what kind of the hydraulic and the mechanical properties. So they try to construct a database for the whole area. Yeah, so that's the part of that. After the drillings and after they take the samples, the original borehole, they're also doing the well loggings. They try to use the geophysical survey in the wells to understand like their geometry of the formation or the fractures, and even like properties, how larger porosity or the permeability they might have, And like I mentioned, they're doing a pumping test there. And even after these several experiments, they will set up the observation system there. So commonly, they will separate to two different depths. One is shallow depth, one is the deeper depth, to observe the groundwater levels in the other area. And they will try to find out where it could be the high fracture area and open a screen there to do the observations. But there will be some constraint because in the mountains, not in the plain area. The plain area is very plain, so it's easy to find out the place to do the drilling to set up the wells. But in the mountains, commonly there's a high topography, so it's not easy to find the place. So commonly they need to find the place. They have the relatively plain area, and they'll be easy for the machine to enter in to do the drillings. So they will have further challenge to find the places. And so the process is here. I try to introduce to let you understand how they're doing the work, but not the detail, only the concept. So construction plant, they try to construct the observation well here. The procedure will be they will doing some site investigations, the field survey and check, land use application, and hydraulic structure applications. That several steps belong to your law or the constraint of the from the government. So for example, in the very beginning, you need to have a map and then try to find out where could be the potential area you want to do the drillings. And when you would like to do the drillings, you need to consider several factors together. Like I mentioned, there will have the traffic, or they have the road, and they have the easy because the drillings jumbo is quite big, so you need to have the place, you need to have the road to let the big machine can enter in, or you need to find a small one to do the drillings. So they need to find the topography map, geological map, and also the traditional, like a Google map, to understand if they have the road to arrive. And find the place, they have the relative plain elevations. And it will be better to find another private land is belong to the governments. It will be easier to apply the allowance because the project is supported by the government. So if you find the place they will belong to government, they'll be easier. So commonly you will find that the observation system in Taiwan is in the elementary school, junior high school, or even senior high school. But elementary school and junior high school is more commonly to observe this station. So like this time we go to the field, you will go to visit elementary school, and we building the systems in their campus, so it'll be easy to have the land for the usage. So the land use is very important part. If you find the private land, you might need to pay the money. You need to rent the lands for the usage, but commonly every year you need to pay the monies, or after maybe 3 years, 4 years, you need to take out the system, or you need to recover the land. So there will be some other problems. So commonly you will try to find the government's land for the usage, or easier to obtain. And the field surveys, the first part you use the map to select the suitable place, and the second part is you need to go to the field to check if the place is suitable to use or not, or if there's any sufficient land area that your device can put there. Okay, so you need to go to the field to check, to survey and check. And after that, there'll be a lot of the processes. Like this is two commonly step. Land use, like if that's belong to the government or belong to the central government or local governments, you need to communicate with them. Is that able to construct this well or not? Okay, and that's the land use. Another is the hydraulic structure application. If you would like to construct like the observation well, the pumping wells, you also need to apply another in Taiwan. It's called the hydraulic structure applications. You need to get the allowance, and commonly this one is managed by local government you need to apply a proposal to them, and then they will find the experts to do the evaluations. If this plan is suitable or it do not have the other impact to the environment, and then they'll be allowed you to do the constructions. Okay. So commonly there will be the main concept: paperwork first, and then go to the field to understand, and then if the price is okay, and then you need to apply for allowance, meaning for a land use, and then hydraulic structure usage or the application. And when you would like to do the select, like this is the procedure, but how you make decisions, this place is suitable or not, yes, you have some factors like geology and topography. I mentioned that. Commonly, they want to know more general properties in this area. So each of the formations, they will try to find at least one of the wells, because they'll take the core sample to do the experiment. They'll do the observation system or do some of the physical survey there. So geology is a very important part. They can select the suitable unit. And topography, as I mentioned, if they are high elevation or high variation for the topography is not able to enter in, they'll be difficult. And mountain triple water supply, because when you do the drillings, commonly you need to have the target, like is there any one they need waters. Although this one is like the survey, we just provide the background survey to understand if this area have groundwater resources. But if we can have the wells and they also be able to use directly, and they'll be good, because you already spend money for the drillings. So if you dead waters can be directly used, and then you have some of the demand from nearby, and they can directly use him for the water resources. So they also try to find out, is there any demand from this area, if there any some of the society they need the waters, okay? And there could be more potential area, and then you can try to find the wells around or inside that area society. And the third part is the groundwater potential, because the main purpose is to find the water resources. So if you find a place like in the top mountains, they do not, you will not expect there will be the groundwater there, because groundwater, they need to have the watershed concept. The water will collect at the area, and some of the places they have like a kind of valleys, and that will be easy to find to let the water collect there. So there will be high potential to have the groundwater resources. You will not find the mountain, the top of the mountains to find the groundwaters. Okay, so groundwater potential areas commonly there will be the watershed concept. So you need to use the watershed concept and to find the suitable like outflow channels or outflow area. There'll be more high possibility to find the waters. And traffic situations, what I mentioned, if you do not have suitable road for the device to entering, they'll be difficult to have the drillings. Okay, so the traffic condition is very important. Although that's not a directly match or directly connect to what we want to do, the groundwaters, but that's will affect your drillings work. And then use a management institute, and because as I mentioned, private land is not easy to obtain or get allowance, and government's land will be easier. And some of the institute is not easy to allow you to drilling the wells. For example, in the Yangming Mountains, right now geothermal issues. We know geothermals is very high potential in the Yangming Mountains area, but the Yangming Mountain area is the national park area, and it is not allowed you to drilling the wells to have human activities inside. Okay, so even though they have high potentials, we still not able to use the land. And similarly, in some of the places, they also do not allow you to drilling the well to do the observations. You need to get allowance, especially for the protection area. They have very high sensitive to the environment. So commonly they do not allow you to enter in to do some human activities. Okay, So this one is also quite important part. And sometimes when we got stuck, it's due to these issues. We cannot get allowance. For example, in the past, we tried to drilling wells in the coastal area. In the coastal area, there's just the land. You might imagine, oh, we just find a place suitable, we can do the drillings. Okay, no. Because you need to understand that land belongs to the local government. And they have some protections institute to manage their land. And they might have some overlap because, I don't know, in different countries, in Taiwan, even the location, they be specified for managed by one institute. But the nearby, also, they will be in charge of these kind of conditions. Like they might have the farm issues, they might have the potential protection for the coastal area, and they might have some forest. So even we find a place is just in the coast, but we might need to meet 3 different kind of institutes to manage these issues. So we need to gather their allowance, and their allowance apply individually. And also the hydraulic structure applications, there's another for the management part. The land is a part, okay, and then the construction is another part. So the different department you need to pass, and commonly it might spend half years or even longer. So if you would like to get allowance to do the drillings, the administration work spend quite much time. Half year is very common. So if you have the project, you want to do this work, you remember that you need to keep the time. To keep the time for half years to do this kind of administration work. And then you can do the really work for like the drillings and the machine entering. Okay, so the time is become longer. If you just got a 1 year project, you need to be careful because like if their contract asks you to have more than half years observations, but you spend half years to do this work, and then you might spend 3 months to do the drillings, and you only have 3 months observations, and then you cannot match the contract. You will get the problems, okay? So this one, sometimes you need to do further or do faster or do the work before you got the project work. Or you need to communicate with the agents, mentions that, oh, we might have this problem, so we need to extend longer time, and you'll be able to finish your work. Yeah, so there'll be time step quite complex. Although it's the application part, it's not easy to understand. If you really do the work, especially for local student, I don't know international one, but a local student, if you want to do this work, commonly you need to follow the step. Okay, and the hydrogeological drill and course records, when you go to the survey, hydrogeological survey, you start doing the drillings and then you got the core samples. So you try to recognize the materials. What could be the materials there? What kind of rock system and the colors? And is there any organic inside or not? And hydrogeological surveys in the wells, that could be like a topography, geology, and core data collections, and borehole topographic survey, and well loggings, groundwater flow, temperatures, conductivity surveys. Commonly, this quite depends. Okay, yeah, depends on the contract. If they require you to have that, you need to match the requirement. And integrate the data and design the Baker hydraulic test intervals. When test the data analysis, integrated the test result, and decided monitoring depth for all the intervals. So when you make decision for specific locations and then start to do the drillings, that will be the first part. Drilling the wells and have the core sample and do some of the work. And that's what you take out. But in the wells, you have several information you need to collect. And topography is mainly for the well top elevations, because when we're talking about the groundwater levels, it is compared to the mean sea levels. Okay, so there's the absolute quantities, and you need to know the top elevations of the wells, and we measure the depth to waters, and then you can know exactly water level depth, water level elevation. Okay, so that's very important part. If you do not have exactly the coordinate system for your wells, you might get problem for this data. So commonly we will measure the coordinate, not only the elevation, also the SY directions, okay, coordinate system. And the elevation is very important part because you need to quantify the water level, okay? And you will have some of the others, geology information or the cold data collections because before doing the drillings, you might have the imaginations because you collect the geological map and data from the reference. And you might have your imagines what kind of formations look like or how deep you might meet what kind of the formations. You will have these images first or you have your concept first. And after the drillings, you might find they'll be consistent or inconsistent. And if that is not a match your thinkings, you need to do some corrections. Or the map do not provide correct result, you need to do some correction, okay? Like in the Yuanshan #1 wells for the geothermal system. They do the drillings and they expect the Shih-Jung sandstone is around maybe 500 meters. But after they really do the work, the Shih-Jung formations may be 800 meters, okay, the thickness. So that means they out of their expectations, they might due to like the slope or the dip is different from the surface because we'll only see that on the surface. But when you do the drillings, the formation is not linear. So they might have the teal or they might have the curve. So they become much deeper or they become much thicker for the formations. And it affects what? Your budget. Because Shih-Jung sandstone is very rigid. So you need to spend much more money for the drillings because they weathering very quick. So your drilling bit is damaged very quickly. So spend much more money for the drillings. At the time, it's become longer. And when your working time extend, that means you need to spend more money because the workers, when they working one day, they count the days. Okay, so working 3 more months, you need to pay 3 more months for the salary, okay? So that's quite expensive. Yeah, but there's no way because we only have that information to do the predictions, to have the plan. But after you do the work, you might meet the problems and try to solve that step by step, okay? And inside that will be borehole topographic survey. They try to using the photograph, using the camera to take photos for the whole borehole, and they can try to delineate like a fracture area and also where could be different kind of materials. Because core sample, when you take out, they are already be disturbed. They have the disturbances for the core samples. But for when they inside the wells or when they in the rock system, maybe a little differences. They already released the stress, but inside is still under the stress condition, although they might have expanded. And fracture is another because this kind of system, they try to find out where could be the water resources. And we know that groundwater flow in the rock system is mainly flow through the fracture system. So they need to identify where is the fracture area. And that's a very important part. So they using the photograph. And using photograph, they can also using some of the digital analysis. So they can try to using the, like right now we can use AI, but in the past using only digitalized analysis. And that was a part because they just identify the fracture zone or fracture density. But we don't exactly know if they are permeable or not. So after that, we still need to do some of the tests, like a Packer test. They're using the Packer hydraulic test. We find there will be high fracture in this interval, so we try to use the Packer in the wells and put the pump inside. So we will be able to do the pumping test only in this interval to see if these fractures is easy to have the water flow or not. Okay. So that's the Packer hydraulic test. And another part they also use in the well loggings, I mentioned, geophysical well loggings. There will be several kinds of methods they can try to detect. If they have the, like I mentioned, the clay, they have radiations, gamma rays, and they might have other resistivity and the conductivity like that, and others. Yeah, I'm not so familiar with that. And even they will assess the flow, quantum flow. They will have some of the device they can measure the water flow, but not easy, because if you would like to have the horizontal flow, commonly the well is quite small. It's maybe the bigger one is 4 inches, and commonly it's 2 inches. And if there's 4 inches, you can put a device inside, and they will use in the thermal, commonly using the thermal in the central, and some of the sensors nearby. So you release the temperatures, and they'll be flowed with the water, quantum flow. So you will be able to detect the flow directions. Okay, they're using this kind of concept. And another is the vertical part. They have the two, like one put, maybe, I forgot exactly, maybe they have the, like in the central, they put the temperatures increase. And then they have two devices at the upper and lower, and they will be able to measure the vertical flow. Okay, so there will be one of the flow meters in the wells. But honestly speaking, the flow observation in the well is not so useful. Commonly, the error is quite large. Okay, and temperatures is also another, as I mentioned, temperatures is a background. Commonly with the background temperatures, to understand the water temperatures, if they have high variation or not. And commonly in the deeper groundwater system, the temperature is quite constant, because I mentioned that they could be keep the same. But if the temperature have the high variations, they might imply they connect to the atmosphere quite smoothly, so you will able to see the temperature variations. Or you might have some other source, but commonly it's quite stable, around 20 degrees Celsius. And conductivity survey is to, I'm not sure, also geophysical survey, I guess, okay. And then you need to make decisions, integrate data to design the Baker hydraulic test. So we want to find the main source. So that's the reason I mentioned they will try to measure the fracture area and focusing on the fracture area. So they using several kinds of drilling data and also the core samples to identify where could be the high potential zone. Okay, and then they using the Bakers to do the test. So they need to make decisions. Commonly, they will one wells around 100 meters. They might separate to maybe 5 or more depth to do the Baker test to detect the hydraulic property. And after that, you do the data analysis, because they just, when we do the pumping test, we just got the drawdown curve, and we need to do the inverse or to using some of the theoretical calculations, and then we will be able to assess the hydraulic the data. And then all the results be obtained, and then as I mentioned, they will do the observations. So they will make decisions where could be the suitable place to set up the screen, to set up the wells, and then they will do maybe another drilling to set up the observation wells. Commonly, for this kind of system, we do the geological survey well first, 100 meters. And after that, they will make decisions to have the 2 observation wells, as I mentioned, shallow and deep. And this well, the original borehole, they have 2 kind of methods. One is to, how to say that, quokong, to let the original borehole become larger. Okay, I don't know how to say in English. They have term. So original one, they can use in more larger. Or originally, they might just put 2 inches, because commonly for this kind of geological borehole, they use in a small diameters system, because there will be save money. You don't need to use in a very large borehole. You just do very quickly the small one and gather the sample and do some of the survey. So that borehole is not sufficient to do the observation. Commonly, when you like to do like a pumping test, you might need to have the larger scale. So at least the 4 inches is more suitable. So they will try to enlarge the original borehole. After they do this kind of work, they know where could be the suitable place to put the screen and the well. So they will make decision in this area. So they will drilling to that depth and then put the well casings inside and put the screen. And then they will be able to do the measurements at that depth. And another, they will drilling another borehole, like one of that is shallow, one of that could be deeper, because they already know where could be the suitable place to do the observations. This one, okay. So they will drilling another borehole to do the work. Sometimes they abandon the original one and do the drillings for the 2 new one. That depends on the condition. Okay, so after you set up the wells, you finish the observation well, and then you can put the pedometers inside to do the measurement. And after you, this is the in situ work, and then laboratory experiment, they were using the core sample like to do the rock property test, soil property test, and permeability test. Rock property test, because this is in the mountains area, so commonly the material is mainly for the rock. So there'll be rock mechanics. You need to do the rock mechanics test to know the strength of the conditions or to measure the stress conditions of the rock system. Okay, so there'll be the rock property test. And another could be like fractures. They might also have some fracture. They might using some of the fracture tests. I'm not sure exactly the detail. And another is the soil property test. Because in the system later we will see that they separate to maybe three main kinds of the materials. Shallow part, they call this a regolith. They define as a regolith, and meaning for the weathering materials. So they will approach to the sand, not sand, the soil, okay. And the deeper one, or the interval, the between the rock system, they have some fracture system. So that's a fracture rock system. And balance, they'll be entire rock. Okay, so they commonly separate to regolith and fracture and entire rock. The concept is like that, okay. So they still have the soil properties in the shallow depth. They also quite depends. Some of the places, they could be several, maybe dozens of the meters, okay. But some places maybe only several meters. That quite depends on the condition. And permeability test is also the same. They try to do the permeability test in the lab. But remember that when you have the permeability or hydraulic test, they have a scale effect. We emphasized that last semester. Scale effect means that when you take the core samples, what you obtain is only for that scale. Your K value is only for that scale. And when you do in the like a slug test in the Shih-Jung, because slug test is very tiny disturbances for your quantum system, so the representative scale could be only several meters, okay. And if you do in the pumping test, the inferences area could be dozens of meters or even hundreds of meters. So the representative properties will be relatively larger. They become like equivalents. We call it equivalent T values or the aquifer T values. So be careful for the scale effect. Larger scale, you commonly got the larger hydraulic data, hydraulic values. Small scale, what you got is only relative small quantities. So the scale effect will be proportional. Okay, so your scale increase and then your hydraulic properties increase. They'll be proportional like that. So be careful for that, although we do the permeability test in that. But commonly when you do the in situ work or doing the simulations, this data cannot be used. Yeah, although we still use that for our preliminary setting. And here's the photo chart for the hydrogeological survey for the whole area. Although in Chinese, I try to translate. Okay, so the start for the survey, and then try to collect the background information, as I mentioned, using the paperwork or the like a reference or the literatures. Try to collect some background topography, geology, or even in the past that may have some of the core sample. Okay, so I try to collect the background information. And after that, you make decision to do the test, okay, to do the drillings. So after you have the drillings, you will able to do the some of the tests, like photograph, loggings, and the WAV or the diameters or ground flow temperatures and conductivity. Several tests, so there'll be several like that. And commonly, as I mentioned, they want to identify the fracture area. The main part is how fast the water flow, and how much water it can supply. So there'll be T and S, commonly is T and S. So the orientation for the fracture will be a very important part, the fracture system survey. And then you make decision to set up the hydraulic test intervals, okay? Because I mentioned they want to do the in situ test, and then doing the test for the CO system, packer, and to get the T values and S value. T transmissivity, S storativity, okay? And the method they separate because in the rock system, they are not like a traditional system. So they are not easy to use in traditional pumping test or slug test. Although the concept will be similar, but they use in a different kind of the theory. As I mentioned, that when we use the packers, they become the CO system. They become like a kind of confined system. But they are not really confined, and the other is they are fractures. And when we're talking about the tight solutions, they are meaning for the porous material. They are more uniform like that. We assume they will be homogeneous, isotropic. But in the system, they might not. So they're using another. So like they're using pumping, injections, slug test, and also the pressure pulse test. But I'm not familiar with the detail. If you're interested, you can actually search for that. So after that, you got the T and S values in different intervals and got the whole several press. You can have the more data for that. And got the test observations and go back to do the analysis to understand, reverse the T and S. And then you can got the final result to make this, some explanations and integrate together and finish the work. Okay. Yeah, this is for the general concept, but this one is for mainly for the rock system, not for all the hydrogeological survey. And here's the concept for the lithology. As I mentioned, that they commonly separate to could be three kinds, but you can take a look. They try to collect the literatures, how they describing the rock system for the storage or the permeabilities. Okay, so different researchers propose the different kind of concept. Like this one, they're using the shallow depth could be meaning the water storage area, and with the deep depth, the water storage become very few, so they become like this kind of curve. Okay, and this one is major part. And another is health. He using this kind of concept because he mentions the central part could be fracture system. So they're using the fractures to demonstrate this kind of system. But they might have the, we call it preferential flow path, the larger fracture area, like there could be the fault, okay, major fault or the major fracture. And shallow depth still the most water storage there because they like the weather or the very, very damaged area, okay. And this one, they're using the concept like the shallow depth is like a soil. We have the waters and then becomes weathering zone, and then they have the fracture zone. And then after that, they'll become the entire rock system. Okay, so there'll be several, like they try to identify that. And in this study, although it looks like only two, but yeah, they could be more precisely. So the shallow depth is called regolith. They define as the regolith. But the deeper part, although they use it as the bedrock, but in detail they can separate to maybe not. Can we say damage zone? Maybe not. The fracture zone. Okay, like this one, they might have fractures, but for the deeper part, they reach the entire rock, so they do not have the much of the fracture system. Okay, so they consider the reference and then decide hydrogeological concept models and then separate the layers, like aquifer systems, and develop the hydrogeological profile.
So in their work, they commonly separate to, or they try to identify where could be the regoliths and how thick the regoliths might have, because there's the meaning for the water storage area. Okay, so this one is the main groundwater storage area. So they try to define how deep they might have, and they were able to using data depth to provide the water resources for that. But honestly speaking, for the fracture area, sometimes we're still able to find very huge water resources there. And this is for one of the examples to show in the well logging. They're using acoustic waveform logging, so you can see they have the different wave velocity. Some parts they have high velocity, some parts have the small velocity. High velocity may imply they have more rigidity, okay, or more complete the entire rock. And have some of low velocity, imply they might be more damaged, okay, like that. And they have some of the, what is this? Amplitude. I'm not sure exactly. Yeah, I do not put the whole content here. And that just meantime, they also using maybe some wave or some of the others information together. And this part is the photograph, as I mentioned. They were using the photograph for the whole, using the camera to put in the wells to do the records. Okay, so some of the darker line means they have the fracture system. Okay, because they using that's the 360 degrees. So of this, they try to use the hole, but they become open like a plane. Okay, so this one exactly they are covered together. They are a hole. They use the camera to put inside so they can expand like this. So originally they could be 3D system, but we were able to see, oh, this is the fracture area. They have some damaged area. Okay, and they will consider like the well logging information and also their photograph, and then make decisions where they would like to put the packers to do the test. Okay, and I'm not sure exactly this one. Okay. So they put the packers to do the test, so they will be able to obtain the K values. Okay, they hydraulic test the result. Okay, so it means they have 7 points to do the packer test, like this one, and then do the test here. Put packers here and do the test here. And each of the depths, you can gather the different K values. And you can also see that even in some of the places, we see they have high fractures area, fracture zone. But their K is not high, okay? So fracture is not exactly identical to the permeabilities. So they need to identify where could be the main fracture area, the water will easy to flow. Like this one, there's a K value is relatively higher, 10 to minus 6. They do not put maybe the meter per second, okay, it's very small. So the 9 is relatively small, 9 is very small, 7 is not high, but 6 is still okay. So I hope you can have some general concept like 10 to minus 5 is around sand material, and 10 to minus 6 still the sand, like it could be approach to the fine sand, okay, from the medium sand to the fine sand. If we compare to the porous material or sedimentary material, and 10 to minus 11 or 10 approach to the clay, seal and clay. So that means this area they even, or we can say they are not easy to have the permeable materials. And 9 and 7 still 7 still okay, and 9, 8 is relatively small. But compared to the rock system, because rock, they only able to have the free transmit in the fracture area. So commonly the K value will be small. So 8, 7 still okay, but after that 9, 10, 11 is very, very small. It's not have the water, not easy to have the water to flow in and flow out. Okay, so each of the test result, you will be able to know the K values. Okay, and another information, I hope you can understand that even these values, if you directly read this value, you might imagine, oh, this one have the high K and this is low K. But remember, if you are a groundwater hydrologist, you need to take a look at the original data. Sometimes they doing this kind of inverse, we using the curve fittings. And the curve fittings, they could be quite arbitrary. Curve fitting, that means
We have the observation data. We have the theoretical theory or the curve to do the fittings. And we can use that to inverse your T value or K value. But sometimes the curve fitting is very poor. Okay. They might imply that they're using the wrong theory to do the fittings. Or they might using the wrong experiment, or their experiment is failed. It's not correct. But they still use that to do the fitting and got the one values. Okay. That's a very big mistake, and we commonly see in the project work, especially for a consultant company. If they do not have the strong background, commonly they just fit. They do not care about the quality for the fittings. They just, I put the data inside and then do the fittings. I got the result, the values I just put down there and submit. Okay, but the quantities might not correct. The fitting might not correct. The experiment might fail. Okay, so if you are expert, you need to check if the data is correct, if the experiment is correct, or that's useless, that's meaningless. Okay, or that could be wrong. So be careful for that. Again, like when we take the core sample, the same. You got the data for the borehole data, right? You got there's what kind of material there. But honestly speaking, commonly they have large uncertainties. Yeah, for the following lectures, we'll let you go to take a look at the core sample. You will be able to see, that's how can you recognize the material by your eyes, okay? That's not easy. And especially if you do not have some other background, they might also have some other covers. You don't know, you need to remove the cover first, and then you got the real one. If you do not remove the covers, you got it totally wrong. Although we already remove the covers, okay? Because when you do the drillings, we're using the drilling mud. So when you also take the core samples, they have the drilling mud covers outside your core. So you need to use some of the device to remove the drilling mud, and then you can see the really material inside. Okay. But if you do not do that, all of that become like clay or the mud. Okay, that'll be totally wrong. So be careful for that. Data quality sometimes is not easy to control, but that's a very important part for you to understand that. That's all. Okay, so maybe we take 10 minutes break first.